All right, the fundamental ideas. We put the fun in fundamental ideas. Look, here we are building this thing. We're kind of in the beginning of trigonometry here, and we're gathering these identities, and you can memorize them, and you should. And so I'm going to give you some proof tonight. And I know you're going to be saying, Charlie, why do I give a crap about that? Why do I need this proof? And I'm asking you to take me at my word. I work hard at this, and I want to help you guys the very best that I can. The reason that you need this is because we're going to play this game later, and we're going to be trying to prove trigonometric identities. And when we do, we're going to be using these rules like pieces, and we're going to be renaming things. How can you rename this thing? How can you prove that this thing is true? And you're constantly going to be going back to this table, this fundamental identities table that includes the reciprocal identities, the tangent and the cotangent identities, and the Pythagorean identities. And you're going to have to kind of understand why they work the way they work. So let's start by showing them to you. And then so here's the tan identity. Tan of theta can be restated. That is, can be identified or can be defined in many ways. And one way is to say that it's the sine of theta over cosine of theta. And that's, to me, it's not obvious why it's true, but I think it becomes obvious, and I think I can prove it to you just given a little bit of algebra. And I also want to tell you that cotan of theta can be defined as cosine theta over sine theta. I don't have a good way to help you memorize which is which, to help you memorize both, but it's one of those things that if you can memorize one, you can memorize them both. So remember that cotan of theta is cosine of theta over sine of theta. And the other one is the other one, right? So cotan is cosine over sine. All right? And that leaves tan of theta to be the other side. So let's prove this if you don't mind. So here's some proof. And if you're going, yeah, dude, I don't care about the proof. I'm making the argument to you that you should care about this proof in particular because you're going to use this proof in pieces that you're going to have to see things and go, oh, that's what that is. This is where I replace this with this. And when you get good at that, you'll see, trig will be, all right, I don't want to sound too nerdy, but it'll be kind of cool. Cool in what way? Cool that you'll know what you're talking about. And that's kind of a cool thing sometimes when difficult concepts become more obvious and become more doable, they become kind of cool. So here's my proof to you, if you don't mind. So look at this for a second. We know that tan of theta, right? We know that tan of theta, right from geometry, we know that tan of theta is, what is it? Opposite over adjacent. That's what I'm going to say. TOA, right? So you're saying to me, what the hell does that thing have to do with this thing? And I'm saying to you this for a second. Look at this for a second. So let's take this, if you don't mind, let's move these pieces down. And how is it true that sine of theta over cosine of theta breaks down to opposite over adjacent? So let's bring these pieces down to here. And to, I don't know, where are we going to put this thing? And to here, okay? So let's see if this works out for us. So here's our solidus, our fraction bar. Thank you, Mr. Cage, our fraction bar. And we know that sine, right? Sine is the same as opposite over hypotenuse. Isn't that right? So it's opposite over hypotenuse. So all I'm going to do is I'm going to take this piece down, and I'm going to put a replacement piece in, and I'm going to put opposite over hypotenuse. And I'm going to ask you to believe that this right here, this whole thing together here, is sine of theta, isn't it? So there's my replacement piece, if you don't mind. And then I'm going to take my cosine value here. So here's cosine, and we know that cosine is adjacent over hypotenuse. And I wonder if you're saying it in your mind right now too. I'm saying so, katoa, to try to memorize these things, right? Now I'm asking you, do you remember the rule for complex fractions? Because this is a complex fraction, isn't it? So this is what this is going to look like. I think this is cool. I think this is going to make sense. Right, so let me remind you what happens with complex fractions, right? Complex fraction is A over B over C over D, and can be simplified as A over B times D over C. That is to say, when you have a complex fraction, you take this piece, leave it the way it was, and I did, and you take this piece and you bring it up as its reciprocal. So check me out here. This D is this D, right? And this C right here is this C, right? It's just its reciprocal. So I'm going to apply this rule right here, this rule, to this mess up here, yeah? So if you don't mind, I'm going to take this, I'm going to bring this down. I'm going to take this opposite over hypotenuse, that's my A over B, isn't it? My opposite over hypotenuse, right? And here, this multiplication sign, you guys, little cute pink multiplication sign right here is this little cute multiplication sign right here. I'm just following my complex fraction rule here. And then I'm going to take the reciprocal of this thing, right? So hypotenuse in the denominator turns into hypotenuse in the numerator, doesn't it? And adjacent here. Now I'm asking you to stay with me for one more second because I'm going to do some yellow stuff. Opposite. Can you see it happening yet? If you're looking at the work over what I'm working on right this second, hopefully you're going, yeah, I got that. Shut up. Move on. But let's just see it, right? Right? So if I multiply this, I'd have hypotenuse over hypotenuse, which goes to 1. So I'd have opposite times 1 is equal opposite. And 1 times adjacent is adjacent. And isn't this this? And I swear, I'm so worried because I think you're sitting there going, so what? I mean, it's too obvious. Well, how's that going to help me? I'm not into this whole clever thing. Dude, it's not the clever thing. It's a piece that you're going to need when you get 20 pages from where you are in your trig book right now, I promise you. So you got to kind of start seeing these patterns, okay? So proud of you guys. Please keep up the hard work. This is going to pay off for you. It's going to be a cool place when you really, really get this. And I'd love to hear comments.